In this lesson, we will determine the equation of a tangent line to a curve. The learning outcomes of this lesson is to obtain the slope and equation of a tangent line to a curve using differentiation method. Tangent line is a line touches a curve at a given point. So this figure shows a curve y is equal to fx with a tangent line touch the curve. The tangent line is shown by the red line. It touched the curve at point K, A, F, E. First, we look at how to find the slope of a tangent line to the curve. We have two steps here. Step 1, we will find the derivative, that is the dy dx or f prime x. And after that, we are going to substitute x is equal to a into the dy dx or f prime x. And after that, we can obtain the slope of the tangent line. Example 1, we want to find the slope of a tangent line to the curve fx is equal to square root x minus 3 at point x is equal to 7. So this is our fx. X is equal to square root x minus 3. Okay, we need to write it in powers of n, in power rule. Okay, so we write it as x minus 3 powers of half. Okay, in step 1, we want to find the differentiation of fx. So f prime x, we use the composite function and chain rule. So we get the f prime x as 1 over 2 square root x minus 3. And after that, we are going to substitute the x with 7. So we get f prime 7. After you simplify, you get 1 over 4. And thus, the slope of the tangent line is 1 over 4. Okay, in this example, now we look at how to find the equation of a tangent to the curve. We have 3 steps here. Step 1, we need to find the derivative dy dx or f prime x. After that, in step 2, we substitute x is equal to a into the dy dx or f prime x to get the slope of the tangent, and we name it as n. And lastly, in step 3, we are going to determine the equation of the tangent, okay, using equation y minus y1 is equal to mx minus x1 or y is equal to mx plus c. Okay, in this example, we want to find the equation of a tangent line to the curve y is equal to e powers of 3x divided by square root 4 minus x at x is equal to 0. First of all, if you look at this, the y, okay, if you look at the y, it is in the quotient form, okay. Let's say we assume it as in the form of u over v, alright, where the u is comes from the numerator part, e powers of 3x, and the v comes from the denominator part, that is the square root 4 minus x. And after that, we find the u prime, differentiate u, we get u prime 3e 3x, and we differentiate v to get the v prime, and here negative 1 over square root 2 square root 4 minus x. Okay, we use the chain rule to get the v prime. Okay, now if you look at here, the y, it is in the form of quotient rule, so we need to use the formula for quotient rule to find the dy dx. V u prime minus u v prime divided by v squared. And after that, we are going to substitute the u, v, u prime and v prime into the formula for dy dx. Alright, we replace the function u, v, u prime and v prime. And after we simplify it, we can write the dy dx as 3e 3x square root 4 minus x plus e powers of 3x divided by 2 square root minus 4x divided by 4 minus x. So that is the dy dx at x is equal to 0. Okay, in step 2, we are going to substitute x with 0 in the dy dx. So if you look at here, every x we replace with 0. So after we simplify it, we get it as 25 over 16. So this is actually the slope of the tangent line, or we denote it as m. Okay, we write it as m. So m is 25 over 16, or the slope is 25 over 16. In step 3, we are going to find the equation of the tangent line. So when x is 0, okay, we replace x is equal to 0 in the formula of y. So we get y is equal to half. So the point where the tangent line touch the curve is at 0 half. X0 and y is equal to half. So we use this formula to find the equation of the tangent line, y minus y1, x minus x1, where y1 is half and m is 25 over 16, the value for dy dx, and x1 is 0. So after we simplify it, so we get the equation of the tangent line as y is equal to 25 over 16x plus half. Okay, here is the exercises related to equation of tangent line. You can try it at home. We will discuss it in the next lesson. Okay, that's all for today.